In this learning objective, we're going to look at SOH-CAH-TOA applications. We're going to do two different things. All right, we're going to look at multi-step SOH-CAH-TOA problems, so ones you can't solve by just a single trig function, and then also some word problems that have to do with SOH-CAH-TOA. All right, so in solving a diagram that involves multiple angles, there's a lot going on. Just remember, you can only use SOH-CAH-TOA with right triangles. So identify where your right triangles are, and make sure you're only using those as references. All right, so you might have a question like this. We're trying to find this big side x. If you look at what x is a part of, it's part of this big red triangle. And that big red triangle is not a right triangle. All right, this angle up here is not a right angle. So we can't find this x directly because it's not part of a right triangle. What we do have is we have two separate right triangles. We have this blue right triangle, which I'm going to draw on the right here. And we're going to have this green right triangle, which I'm going to draw on the left. All right, so we have these two separate right triangles, and we can always ask ourselves, how can these smaller right triangles help us with the answer we want? And you can see, if we can figure out this blue part here of this smaller right triangle, and this green part here of this smaller right triangle, if we combine those two pieces together, then we're going to get the actual big value of x that we want. All right, so how can we do that? Well, we just use SOH-CAH-TOA. All right, in this first one, we're going to call this one, let's call this what, y, and this z. All right, so we're going to figure out y. All right, it's the opposite and adjacent sides. We're going to use tangent of 50. Goes the opposite side over y. Multiply by y. And divide to get y all by itself. All right, so now we know what y is. We'll put that in a calculator at the end. And then we can do the same thing for z. All right, so z is 36 degrees. We also have the opposite and adjacent sides, so the tangent of 36. TOA is 85 over z. Multiply by z. Divide to get z all by itself. And now the x value we care about is just that y value plus that z value. So I'm going to type those into a calculator, again, using Desmos, and then make sure that your calculator is in degrees. All right, so y is 85 divided by tangent of 50. And that ends up being about 71. I'm going to add to that 85 divided by tangent of 36. And together, that gives me 188.32 when you round. So 188.32 is the length of that x. We have to get there in smaller chunks. All right, here's another type of problem you might see. Again, this x, if we look at the triangle that x is a part of, it's this kind of skinny triangle on the right, and that's not a right triangle because there's no right angle in there. So let's look at what triangles we do have. We have this blue right triangle, which I'll put here. All right, so this blue right triangle. It's the smaller one. We also have this big green right triangle as well. All right, so using the big green right triangle, we could figure out this whole side here. Let's call that Z, why not? And then using the smaller blue triangle, we could find out this side here. We'll call that Y. And how do we figure out the X we actually care about? If we take the big side Z and we get rid of that blue part, that's going to give us X. All right, so really similar to what we did last time, we're just subtracting instead of adding. All right, so first let's find y. All right, again, we have the opposite and adjacent side, so we have the tangent of 56. You could also use cotangent, but SOH-CAH-TOA is the first one that comes to mind, so tangent just makes more sense. Tangent of the opposite side, 115, over the adjacent side, y, multiply by y. That's exactly what we did in the last example. And then divide to get y by itself. And then same thing for z. All right, tangent of 35 is 115 over z. Multiply and divide by tangent to get z by itself. 115 tangent 35. And then we know to get our final answer x, we're going to take that z number. So I'm going to type that in first, 115 divided by tangent of 35. And I'm going to subtract the y number, 115, tangent of 56. And when I do that, it comes out to 86.67 when you round the 2 decimal places. All right, so that is how you can figure out a value when it's not part of a right triangle. All right, use the right triangles you do have and add or subtract at the end to get the actual answer you care about. All right, so here's one for you to try on your own. All right, figure out how you can figure out this x based on what you're given. All right, the answer you should get is 143.04. So this is very similar to the first example we did of this type. All right, we have these 2 different right triangles, one on the left and one on the right. So on the right hand side, we can figure out this y value. The left hand side, we can figure out that z value. You add them together and you get that full x value that you want. All right, so now the next half of this video, we're going to focus on doing word problems that are going to involve SOH-CAH-TOA. Really the only strategy you need to know for doing these word problems is draw a picture, figure out where your right triangle is. All right, because once you have a diagram labeled with your sides and your right triangle, then it's the same thing we've been doing for the rest of the unit so far. All right, just finding missing sides and stuff like that. All right, so an electrician is working on a utility pole. The pole measures 40 feet tall. In order to secure the pole, the electrician must run a wire from the top of the pole to the ground, and it should make a 70-degree angle with the ground. How long must the wire be? All right, so the first thing, try to draw a picture that demonstrates this situation. All right, so I'm going to go ahead and draw it, and we'll come back together when I have it drawn. All right, this is the diagram I came up with. So we have this electricity pole that's going to be straight up, and it's 40 feet tall. I have this wire that's connected to the top of the pole, and it's connected to the ground. And we know it needs to make a 70-degree angle with the ground. The question is, how long is that wire? So if you think about this just as a right triangle, we hope that the utility poles are built well, and that forms a right angle. So this is the same thing as this problem we could have done multiple learning objectives ago. And figure out that x value. All right, so we have the angle 70. We have the opposite side and the hypotenuse, so we're going to use sine. So sine of that 70-degree angle is the opposite side over the hypotenuse. It's just like the equations we saw in the first half of the video. Multiply by x first. Divide the x by itself, and then type this into a calculator. So let's see what 40 divided by sine of 70 is 42, around the 2 decimal places, that's what we've been doing, 42.57 feet, because that's the unit we're talking about. All right, so really it's just one extra step over what you've already been doing. Just draw a picture describing the situation, and then just use your normal SOH-CAH-TOA skills to get there. All right, this one, we want to figure out the height of a nearby mountain. All right, so from a hill close to the mountain, blah, blah, blah. You can read the only thing that I realized there's a typo here. That should be a degree symbol. All right, so I'm going to draw a picture, and we'll come back together when we have a picture drawn. All right, so I think up until here, you can kind of draw the picture. So we have this mountain that we're trying to look at from a hill. If I look down, so there's kind of the horizontal that's coming across, right, kind of where my eye level would be normally. If I look down at 21 degrees, I'm going to see the bottom of the mountain. If I look up at 43 degrees, I'm going to see the top of the mountain. I want to know how tall is the mountain. All right, where is the only right angle, guaranteed right angle in this problem? The only guaranteed right angle is when I'm looking straight at the mountain. That's going to form a right angle there. All right, so I have this kind of one right triangle in the top half of my picture, and the one right triangle in the bottom half of my picture. And this is just like one of the problems we did earlier in the video. I can split up into 2 problems. I can figure out the height, which I'll call maybe this part y, and I can figure out the lower height, which I'll call z. Right. The only thing I haven't labeled in this problem is the 5250, because this one's not completely obvious where this goes in the problem. I have 5250 is the distance from the mountain to me, so that is going to be this kind of central line there is 5,250. So now I have everything I need to solve this problem. All right, so for the upper part of my triangle, The opposite side's y, and the hypotenuse, or sorry, not the hypotenuse, the adjacent side is 5250, so I'm going to use tangent. It's a 43-degree angle, and that's equal to opposite over adjacent. This one I just multiply, and I get y by itself already. All right, the bottom of the bottom right triangle, same thing. Tangent of 21 is the opposite side z over the adjacent side 5250. Multiply to get z by itself. Right. And finally, the height I actually care about is that y value I found plus that z value I found. So now I'm just going to plug these two things into the calculator. Again, always make sure your calculator is in degrees because that's what we're talking about. So let's see, 5250 tangent of 43 plus 5250 tangent of 21. All right, all together, that gives you the height of the mountain with some rounding is 69.11. All right, so this one is, again, the picture. This one's a little bit more difficult than the last one, but once you draw the picture, it's very similar to the problems we did in the first half of this video. All right, so here's one for you to try on your own. Our children's jungle gym has a slide on the side. From the ground, you're able to measure the slide ends 15 feet, blah, blah, blah. You can read. So first thing I'm going to do is give you a second to try to draw it. Then I'm going to show you my picture and then give you a second to solve it and then show you my solution. All right, so this is the very basic picture. All right, this red line is the slide going downward. It's 15 feet from the base of the jungle gym. All right, and it makes an angle of 35 degrees. I want to figure out how tall is the slide. All right, so that is the setup. Now try to solve for x. And the answer you get is about 10.5 feet because you use tangent. You don't know anything about the hypotenuse, so you can't use sine or cosine. Solve your equation, you get 10.5 feet. All right, so for this learning objective, we're going to complete a skill check. It's going to be 2 problems. So one will be one of those multi-step diagrams that we had the first half of this video, and then one's going to be a word problem.